Hello and welcome to PTC Express Video Tip of the Month. My name is Leo Green. Through the years, I've noticed that modeling helical shapes, such as springs, especially with variable pitches, seems to raise questions in many users' minds. So today, we're going to discuss one of the best ways of making springs and controlling them that I've come across. So let's jump right in. We'll start with a regular part and go straight into making a curve. I'll sketch it just on a plane here. Just drop in a line real quick. Give it a length perhaps of 5.5 inches long. Then we'll just jump straight over to the variable section sweep tool, where right click, go straight to sketch. I'm going to make a line emanating from that center, dimensioning it such that I can control its length as well as an angle. Now the length of the line will ultimately be the radius, and the angle will be how this line spins. Well, let's take a look at that. If I don't do anything to it, this variable section sweep will yield essentially a planar face. Let's go back to the sketch. Now what I want to do is vary this angle. If I go to Tools, Relations, I can pick that angle, give it a relation that essentially gives it some instructions on how to change. So we'll say SD6 is now equal to perhaps 30, which is about what it is now, plus 360, but I don't want that 360 to be added immediately. That's where I'll use a quantity called trajpar, the trajectory parameter that returns a value of 0 to 1 in length of the sweep. Now you'll notice that we have a bit of a corkscrew going on. If we look back at the relations on the sketch, so go to Sketch, back to the relations, I can then multiply this whole quantity by the number of times I want it to spin now, and perhaps I don't even need this first 30. Now when I call that section done, we have a corkscrew that wraps around 5.5 times. Call that done, and I've got now a surface that has an edge. I can pick this edge and ask now for a sweep that runs along that edge. Perhaps a circle. We can make it any section that we'd like it to be. We'll call that done, make that a solid, hide the first corkscrew surface, and there's our spring. The great part about this spring now is that when I change the length of the line, the corkscrew changes length, obviously, but the number of turns doesn't. So I've fixed now the number of turns instead of the pitch. Now there may be a value to fixing the pitch, and that would be the function that you'd get with the helical swept protrusion. Now, what if I wanted to vary the pitch? Well, this is really cool. Take a look at this. If I go Insert now, a model datum that's a graph, and I'll give it a name, maybe we'll call it turns. Now the idea here is that ProEngineer is asking me to create a graph that I'm going to use to control the turns. Now if I make a straight line, that would be a constant pitch. The slope would be the pitch. The number of turns would be determined by that slope. If I want it to vary, all I need to do is change how this line behaves. I might want to make a couple of arcs on it, something along those lines. Let's make these two radiuses equal to each other. Just to make the sketch happen a little easier, I'm going to call these horizontal like so, and then add some dimensions for the height, which you can call perhaps the Y direction, and then the width, which will be the X direction. And I'm going to take it one step further. I'm going to actually control the X value for this, and that's going to give me a control of how this will, or where the pitch will change. Going to go straight to Modify all these dimensions, where I can lock scale, because I want this graph to be unitized. Make that one 1, make this one also 1, and maybe this one will be, say, 15%. Now the last requirement for a graph feature in ProEngineer is to include a coordinate system where you want the 0, 0 to be. So now I've got a graph feature that I can use for my helical sweep. So I'll drag it before it so I can use it in its derivation. I'll unhide that sweep. I'll go back to its definition and its sketch. When I go to Tools and Relations now, nothing here has changed, and this is where I want to now tell it to evaluate the graph. ProEngineer requires a term called eval graph. That's where I'm going to specify in parentheses and quotes the name of the graph, turns, end quote, comma, and where on the graph. Got to make sure I spell it right. Turns, comma, trajpar, end quote. So that means evaluate the graph, PH, evaluate the graph called turns along its x length, returning the y value for every x. When I call this sketch done now, you see that same corkscrew has now got compressed ends. And if I want my protrusion now to reflect that same change, edit the definition, holding the shift key down, right click until I get my tangent end. I'll go back now and hide the corkscrew, and you can see now I've got some very nice compressed ends. And the compressed ends will stay compressed even if I change the length. Let's change this maybe to, say, 6 inches. The compressed ends are still 15%, just like the graph says. Now, of course, if I want to grind the ends, all I'd need to do, take a look at this. Pick a plane, edit, solidify, specify the area to be removed, and now I've got a ground end. That'll always stay ground. Interesting. So, through the graph, established exactly the number of turns, as well as how the pitch is to change, without respect to the overall length of the spring itself. Which means, if I use this dimension, we'll go to the setup of a flexibility, where I can use that dimension now to determine the flexibility. So if I install the spring in an assembly of varying lengths, perhaps in an engine or something along those lines, I can use this and the spring will be represented correctly. What's more is if I change my mind about this spring, perhaps I'd like it to be, instead of a line, I'd like it to be perhaps maybe an arc. If I choose now this line, go to edit and replace with the arc, I now have a variable pitch spring that wraps around some arbitrary shape. Well, I hope this opens up a couple of options for you. I hope it makes a little bit of sense. I hope that you'll be able to use this in the future. There you go, taking control of a helical shape, variable pitch, super for springs. My name's Leo Green. I hope you'll join us again for another installment of PTC Express Video Tip of the Month. Thanks for watching.